All right, welcome everyone to today's Explainer. If you're a focused learner looking to understand the absolute bleeding edge of financial technology, well, you are in exactly the right place. Today, we're taking an intense, structured dive right into the mechanics of modern algorithmic trading. We're going to map out exactly how to build a trading platform in the year 2026. We're talking architecture, insane speed limits, programming languages, and the real role AI is playing behind the scenes. Let's get right into it.
4.5 microseconds. I want to hook your attention immediately with that number, 4.5 microseconds. That is roughly 4.5 millionths of a second. To put that into perspective for a second, a literal blink of an eye takes about 300,000 microseconds. In high-frequency algorithmic trading, 4.5 microseconds is your entire latency budget. From the exact moment market data hits your network card to decoding the order book, running your complex trading signals, doing your risk checks, and actually sending an order back out, you have 4.5 microseconds. It proves one absolute truth about this industry: speed is survival. Anything slower and your competitive edge completely evaporates.
Okay, let's dive into this and map out our journey layer by layer. 1. The 2026 trading landscape. 2. Architecting for speed. 3. AI, augmentation, not autonomy. 4. The Python performance wall. 5. Rust, the HFT game changer. And 6. The hybrid build strategy.
Section 1. The 2026 trading landscape, a $44 billion crucible.
To really grasp the technology, we have to look at the massive scale of the environment driving it. The global trading platform market has blasted past $44 billion. We're seeing a total convergence right now of crypto, digital assets, and traditional equity markets into one cohesive system. Whether you're building an app for a retail user wanting fractional shares or a massive institution demanding deep liquidity, your platform has to handle all of it seamlessly. And with the intense regulatory scrutiny we're seeing in 2026, compliance and infrastructure resilience, they are completely non-negotiable from day one. Your architecture literally has to be unshakable. So, how exactly do we build that?
Section 2. Architecting for speed, the cloud-native shift.
You know, the shift away from legacy, monolithic platforms isn't just some tech trend anymore. It's a matter of absolute survival in high-frequency trading. If a market spike takes down your monolithic server, you don't just get an error message, you lose millions of dollars. Instead, 2026 platforms rely heavily on event-driven architecture. Think of it like a giant biological nervous system. The message broker is the spine. It handles the intense speed of the markets by instantly firing off asynchronous events, like price updates or risk alerts, across loosely coupled services. If one part of the system is under heavy load, the rest of the body just keeps functioning flawlessly.
Let's ground that abstract architecture into some tangible, essential features. These are the core components regulators and users expect right out of the box today. You've got your identity and KYC layer handling compliance. Then, the beating heart, the low-latency trading engine and market data aggregation. You absolutely need smart order routing logic, secure wallets and custody for digital assets, and of course, rigorous portfolio and risk management. Every single one of these microservices is constantly communicating over that event-driven nervous system we just talked about.
And they do it at a breathtaking pace. Modern message brokers in these setups are processing up to 4 million messages per second. Because it's a cloud-native setup, when market volatility suddenly spikes, the system can dynamically scale. It can jump from, say, 20 container instances up to 200 container instances in just a matter of minutes. This guarantees that whether the market is totally quiet or in absolute free fall, the platform is highly available in executing trades. But hey, infrastructure is only half the battle, right? We need to talk about the intelligence running on top of it.
Section 3. AI, augmentation, not autonomy.
Now, what's really interesting about this slide is how it totally busts the myth of fully autonomous, unsupervised AI bots just taking over the financial markets. Look at how the Financial Market Standards Board plots this. The vast majority of deployed AI, things like volume-weighted average price algorithms or smart order routers, they sit strictly in the system input or system logic layers. Sure, generative AI investment strategies might be incredibly complex, but AI in real-world trading is heavily restricted. It produces signals, but those are tightly guarded by human-designed risk constraints. The human trader and independent gateway controls are always the final perimeter.
Section 4. The Python performance wall.
All right, we have to acknowledge Python's legacy here. Python basically built the citizen quant revolution. With libraries like NumPy and Pandas, it is absolutely the king of the research phase and rapid alpha discovery. But when you move Python into a live, real-time production environment, its fundamental architecture becomes a massive liability. The global interpreter lock prevents true multi-threading. Unpredictable garbage collection pauses create huge latency spikes. In a microsecond money game, a garbage collection pause is literally like your trading engine deciding to take a sudden coffee break in the middle of a high-speed car chase. Plus, the object model leads to major memory bloat. These are just insurmountable bottlenecks for real-time execution.
Let's look at the hard numbers. Contrast Python with a compiled language like Rust. Python's mean latency, 250 microseconds. Rust hits 2.3 microseconds. Rust can push 10 million messages a second on a single core, while Python hits a hard ceiling at just 120,000. Think back to that total latency budget we talked about, 4.5 microseconds. Python cannot even import the pandas library within that time frame. It's just simply too slow for the microsecond game, which perfectly sets up our solution.
Section 5. Rust, the HFT game changer.
And this brilliantly illustrates why Rust is the ultimate high-frequency trading engine. It solves Python's latency issues, and it solves C++'s safety issues. It offers zero-cost abstractions, meaning your high-level code compiles down perfectly without runtime overhead. It offers memory safety without needing a garbage collector, which means zero unpredictable pauses. But most importantly, it gives you fearless concurrency. The compiler eliminates data races and null pointer dereferences before the code is even allowed to run. In an industry where a single software bug can cause millions of dollars in losses, catching these errors at compile time is an absolute superpower.
Section 6. The hybrid build strategy.
So, we're moving from the language wars to a practical, actionable blueprint. Because, let's be real, you do not need to rewrite your entire organization's code overnight. Actually, scratch that. Please don't try to rewrite everything overnight. The most successful platforms in 2026 use a 4-phase smart migration strategy. Step 1. Keep doing your quantitative research and AI model training in Python. It's still amazing for that. Step 2. Export those model weights and decision boundaries. Step 3. Rewrite only the latency-critical hot path, the actual market data ingestion and order execution in Rust. Finally, Step 4. You can actually embed Python directly inside your Rust application for end-of-day housekeeping and reporting. It really is the best of both worlds. Now, if you're a developer tasked with actually building this, these are your concrete tools. You're going to want to leverage specific Rust packages or crates. Use Tokio for your async runtime, pinning critical threads to isolated CPU cores. Use Crossbeam to pass data between threads using lock-free ring buffers. And use ZeroCopy to parse incoming binary market data with absolutely zero overhead. Real-world open-source projects like the incredible Nautilus Trader are actively using these exact crates to successfully bridge Python environments with Rust's sub-millisecond speeds. We have covered a lot of ground today, from the macro environment and cloud-native event-driven design to the strict guardrails on AI and the massive performance gains of moving your execution engine to Rust. So, I want to leave you with this final, provocative question. In a market entirely decided by microseconds, is your architecture truly ready for 2026? Take a hard look at your infrastructure. Thank you so much for joining me on this explainer, and keep learning.